It's my great pleasure to introduce Alan Evans. I'm not sure Alan needs a lot of introduction. He has such a reputation and such an international outreach that you probably, I mean, at least most of you know him. But he's at McGill, the scientific director of the Healthy Brains for Healthy Lives. He's the director of MCN, of course. He's the lead PI of the CONP, the Canadian Open Neuroscience Platform. And I don't know, there's probably a long list that I'm not covering here. But thank you, Alan, for taking this. And he's also like the man who made this INCF, the Canada joining INCF, and that's a great pleasure and a great honor. Thank you, Alan. By the way, he's also one of the reasons why I'm here.
Well, don't blame me for that. Good morning, everybody. What a glorious morning to be in Montreal. I'm very sorry that we're in here, not out there. Global warming has to be good for somebody. So I'm going to talk to you a little bit about the Canadian Open Neuroscience Platform. And I think I don't need to justify to this audience the benefits and the challenges of open science. I'll just briefly mention this slide, well-known slide originally from Sean Hill, which summarizes the complexity of the data that we're facing and the new universe that we're facing, where there's an infinite amount of data out there in the public space that we can all build our careers around. Canada, I think, hits above its weight in the area of neuroscience and neuroinformatics. And one way to demonstrate that is this slide here, which shows that Canada produces about 50,000 papers a year, which is about 1/6 of the US output, and the US is a population which is 10 times the size of Canada. So by such a metric, we're hitting above our weight, and similar arguments could be made for other countries around the world. So I think Canada is well endowed with both neuroscience and neuroinformatics. In fact, half of the people at this meeting, 130 out of 250 are from Canada. So I think we're trying to take over the world slowly. To face all of this data deluge, Canada has actually taken a lead in establishing what is called the Canadian Fund for Canada First Research Excellence Fund, or CFREF. And it's about $3 billion of endowment. And even in Canadian dollars, that's a big number. And if you multiply that by 10 for a US context, that's a very large concentration of funding for high-end research. And it does bring me to point out some of the synergies that already exist amongst these programs. Our own program, Healthy Brains for Healthy Lives, received $84 million from the Canadian government a year and a half ago. But simultaneously, the EVADO program on big data and artificial intelligence, led by Yoshua Bengio, and Yoshua will be speaking very shortly, they received $93 million from the feds. Western University in Ontario received $66 million. And these are just federal funds. You can add to these something like 20% extra in terms of provincial support. So you're looking at about $250 million just in those three programs. This is probably the only slide that I will show today on the Healthy Brains for Healthy Lives initiative, because I'll be talking mostly about the Canadian Open Neuroscience Platform. But to give you an idea, this is 4 main themes. One, the core theme is based on neuroinformatics and modeling, and the 3 application themes make use of the same machinery in 3 different areas of neurodegenerative diseases, neurodevelopment and brain health, and neuroscience, normal brain development and plasticity. But as I said, those are just 3 CFREF programs. There are a wide variety of very large initiatives across the country at CAMH, the Krembil Center for Neuroinformatics, the Ludma Center, the Ontario Brain Institute. You can read all of these yourself. So there's a tremendous endowment across Canada in neuroscience, and particularly with the neuroinformatics bent. So this led us to want to come together and discuss how to put together a patchwork across the country. And we had our first plenary meeting in February 19th of 2018, funded by BRAIN Canada, which is a federal agency. They gave us $12 million basically for glue activities to pull together all of these initiatives across the country. The current status is that we have the network has been launched. You can go to this website, www.conp.ca. It brings together some 18 universities, 19 universities, and all told, 33 partners across the country who are working together to develop a unified Canadian framework. The overall goals of CONP are pretty much obvious to this community: to develop an organizational framework, enhance our cyber infrastructural scalability, enhance interoperability across these data sharing platforms, expand the library of available pipeline analysis packages, develop programs for training, a workshop and user group support, expand our international partnerships, develop a unified ethics confidentiality framework, and build a national CONP communication platform. One of the immediate benefits of this CONP initiative is that it allowed us to take on a role as a governing node within INCF, to join 5 other countries. And we're very excited to be playing a more active role within CONP. So as I said, these are the broad goals of CONP in terms of building an expandable, scalable platform for data sharing, data analysis, open science. These various goals, which are listed here, the domains of interest, have been assembled into 5 basic committees that are led by people with international reputations across the country. Jean-Baptiste Paulin is leading the steering committee, the technical steering committee. Sean Hill, who would normally be here, and he was from Toronto, is leading the End User Forum. Nicholas Stickoff, leading the communications platform, and now along with Lara Boyd from UBC. Jane Roskams from UBC is leading the training program, and Bartha Noppes from McGill, who has a long experience in the ethics of genomics and biotech in the Global Alliance for Genomic Health, is leading the data governance oversight process. We're still in the early stages of the program, and what will be very important going forward is to build synergies across these 5 committees in these 5 domains. We have a steering committee that's made up of these people plus a few selected leading scientists across the country to help us guide the development of the whole platform. The executive director for CONP is Nasser Muya. Nasser, where are you? He's right there. And he has the fun job of trying to corral all of these prima donnas across the country as we're all running in different directions, and NASA has to try and get everybody pointed in the same direction. So we have, we're 6 months into the first year. We had the kickoff meeting, we've established the website, we've launched the training programs, we've established all the various committees, so things are getting underway. We actually do now also have a formal relationship with DELL that was mentioned yesterday by John Collins to help us gather information across the country on the needs, the technical needs of across the country, which is very difficult because when you speak to, for instance, Compute Canada, they say they can project out maybe 2 years. BRAIN Canada wants us to project out 10 years. So that's going to be an interesting exercise. Jean-Baptiste is chairing the technical committee with these representatives from various institutions and initiatives across the country. The technical committee obviously has links like tentacles into every part of the project, so good luck with that, JP. I'll just mention briefly some of the major elements that we can pull together within the Canadian context. One of them is the CBRAIN portal to high-performance computing and more latterly cloud services. So this is equivalent to the US Exceed program. It allows us to pull together all of the HPC sites across the country, about 300,000 processors. And this allows us to provide an underlying platform to all of the various complex workflows that are going to be needed within CONP. Data can be anywhere, computing can be anywhere, distributed computing and data storage. And we have users who can be anywhere across the country on the top end of that right-hand side of the figure. Again, I stress that there's no necessity to be using just big iron on the ground in HPC facilities. We increasingly are using cloud services, AWS, Azure, and so on. I should note that it's not just Canadian HPC sites which are involved in this. We recently established a node presence on the Texas Advanced Computing Center, or TACC. And this is the largest supercomputer in the world for academic science, and they have, I think, more cores on TACC than all of Canada. Pardon me? Just on Stampede, yes. And we've had various other HPC sites around the world, in Jülich in Germany, in Korea, who are also clusters. In fact, one of the party tricks of the CBRAIN team is to put your iPhone as a data resource on CBRAIN. It's a very straightforward environment to add or remove different clusters. Workflows are being developed using either Docker or Singularity containerized capabilities, particularly led by Tristan Glattard, who you've already met from Concordia University, along with Sean Brown. Sean came to us from the Pittsburgh Supercomputing Center last year, and we're very glad to have him leading the CBRAIN program. CBRAIN, in summary, has many features. It's convenient and secure. It's distributed storage with automated multi-point data transfer, so there's no architectural bottlenecks in the CBRAIN platform. It's been around for about 10 years now, so it's relatively mature. We've gone through a lot of pain over the years to smooth out the interface for loading and processing workflows on CBRAIN. Who uses CBRAIN? About 650 users at this point. Hundreds are active at any given time in 131 sites across 30 countries. About 30 million CPU hours are served. We have about 1 million files on the system at the moment. It has support from various funding agencies listed here, and many different collaborative projects, again, listed here. So it's a well-established generic platform. Associated with the CBRAIN platform, out of the McGill site, is the Loris databasing platform that's been around for about 20 years now in increasing levels of sophistication. It was established for the NIH pediatric NMRI study of normal pediatric development. It allows us to consolidate imaging, behavior, genetics, more latterly epigenetics and tissue sample data in a LIMS environment into the Loris framework. I like to make the point that it's a lot more than just a repository for upload and download of data from multiple sites. It's also a front end to an acquisition management environment. So if you're conducting multi-site studies across the country, or indeed across multiple countries, you have a variety of tools for overseeing online, in real-time data acquisition, so that they're concordant with a pre-established protocol. And of course, it's a front end to any number of analysis pipelines, both those at McGill and those from popular workflows from across the world. So many of those are being established on CBRAIN. This is a relatively recent list of, or map of user sites around the world using Loris. Of course, it's constantly changing. And it's worth mentioning that it's much more than just an imaging environment. It supports some 400 behavioral instruments and an instrument builder, which allows us to add in any new behavioral tools that the project under question requires. It supports the Tannenbaum Open Science Initiative at the MNI that's led by Guido Lowe. They're less concerned with imaging per se than wet lab information, IPSC information, essentially a LIMS environment. And over the last year and a half or so, all of the LIMS environment has been incorporated into the Loris infrastructure. You can read a lot more about these two twin systems in these papers which are shown here. Both CBRAIN and Loris are open source on GitHub. But it's not just about what's going on in here. I'd like to particularly draw attention to the Ontario Brain Institute's Brain Code initiative in Ontario. This is a sophisticated environment which is supporting, as you can see here, the 5 colors, 5 different domains of scientific activity in epilepsy and neurodegenerative, neurodevelopment, and psychiatric disorders and so on. And this captures a lot of the data that's collected across the brain code environment in hundreds of subjects, potentially thousands of data sets. It's interesting to note that the brain code, this is the front-end dashboard of brain code, which allows you to get a snapshot assessment of the entirety of any particular project at a glance. It's interesting to note that the brain code philosophy is to make use of a lot of existing components which can be welded together within the brain code environment. And if you want to find out more about this, we have, I think, Steve Struther here and Randy McIntosh there, at the very least, who can speak in greater detail to brain code. But if you want to find out more about brain code, there's a paper here by Anthony Vaccarino, which describes in detail the brain code setup. So I will come on to the discussion of how we're integrating all of that shortly. The whole program is increasingly supported by the Canada Foundation for Innovation, another funding agency which provides us with software developers across the country in Halifax, Montreal, Toronto, and Calgary, who are essentially MATAG repairmen. They're there to help people take advantage of these tools. And Compute Canada provided us with a commitment to 8 to 10 petabytes over the lifetime of the CFI Cyber Infrastructure Challenge and the Brain Canada CONP platform. So we're in good shape there, although these days 8 to 10 petabytes will quickly become not enough. So you've got all of these tools. You have the CBRAIN at one end, the compute platform, various databases. I've only mentioned Loris and BrainCode. There are other ones being used by different groups. The MEDICS system in Quebec City, the Canadian Atherosclerosis Information Network, otherwise known as CAIN. We have to pull all of these things together. So this is a little bit of a confusing slide, but if I do that, it makes it perhaps a little bit easier. We have to deal with compute platforms, data platforms. We're potentially using data lab as an interoperability environment. We have, I think, the 80-20 issue that was discussed yesterday here, that it doesn't necessarily fit all needs, and that has to be worked through within the context of the Technical Steering Committee. John stole a couple of slides off me yesterday, so I'm happy to show them again. This is the current status of the DELL EMC Collaboration, which will be supporting a lot of this activity. In 4 basic areas, we've just demonstrated a 20-fold increase in the use of GPU4 technology from DELL, but we're going to go on and move to algorithm optimization using FPGAs, distributed data storage using Spark and Hadoop and Isilon technologies. That's down the road, but we're getting underway with technical integration of our various teams. Just to restate that again, the acceleration that I just described was for what's a relatively mundane, boring workflow, eddy current correction for large data sets, but it was previously considered an intractable problem. And we used the Human Connectome project, and it would have taken 9 years to run this workflow correction on a traditional CPU environment, and took 150 days on GPU and a few days through parallelization on CBRAIN. If I move to the data governance issue, the chair of this committee is Bartha Noppers. And as I said, she has a long history in the Global Alliance for Genomic Health. And again, people from across the country represented on the Data Governance Committee. They've been doing a survey of CONP partners and resources to find out the various challenges that face different constituencies across the country. So they're in the midst right now of developing a CONP ethics and governance framework. Bartha is a senior figure. She's also engaged in many projects. We're lucky to have, right in the midst of the CONP, Stephanie Dyke, who is a data governance and ethics officer, and Stephanie is doing a lot of the grunt work of pulling all of this together, interacting with the UK Biobank people and with the HCP people and so on and so forth. It's very nice to have someone with Stephanie's skill set in the midst of CONP. So she's working on developing the CONP survey, and she's been looking at data that's available for sharing, existing barriers for sharing, and the main requests for support from CONP fall into these 5 broad categories of consent, confidentiality, commercialization, and IP issues, access to tiers and de-identification, accessibility, and education and outreach. Stephanie has published a number of papers on the issues of data access models, and we're looking into the registered access mechanism, which is somewhere between completely controlled access, completely secure, but not so straightforward for open data sharing. At the other extreme, of course, you have open data sharing when everybody can get access to everything, and that's not necessarily a good idea either. So somewhere in between is a registered access model where only people who have proper credentials from blessed institutions, and that's not just academic institutions, it can be corporate institutions, but there have to be people vouching for your access to the data. So that's being worked through as we speak by this Data Governance Committee. They've built a set of consent codes and categories and essentially to operationalize the process that I just described. How am I doing for time? In the training arena, Jane Roscombe's UBC is leading the charge with a stellar team of people across the country. And I'm happy to announce that the CONP Research Scholar Program has been launched. You can go to the website, www.conp.ca, and start to explore your potential funding for postdoctoral fellows, for PhD students, to develop open science expertise for periods of up to 1 year, renewable. Broad goals are in platforms, resources, analytics, data dissemination. The application deadline is October 1st, so you've got 2 months. Correct. And the first awards will be made in November. So there are the forms, and if you're Canadian, off you go. Find some partners internationally, off you go. So examples of research projects that we're expecting to fund are databases linking key results across organisms or data modalities, open science communication tools for dissemination of high-dimensional sequence data, novel approaches to standardizing large-scale data, and advancements of early-stage clinical targets with therapeutic potential. All of this is fine in terms of technical and logistical support, but there has to be a reason why. And the reason why is increasingly being defined by an end user input. That this is, the chair of this is Sean Hill from Toronto, and their goal is to try and establish exactly what our needs are, to develop stories narrating end user needs, preferences, and desires, identify common challenges in data management and open exchange, and understand the utility of current technology and open science platforms. Increasingly, they will be involved in an iterative two-way process between the technical developers, the process people, and the end user community. We've just seen the arrival of a 30-page document on essentially universal use case requirements that was developed by David Rottenberg at CAMH. And this will provide high-level requirements for CONP interoperability. The platform the platform will maintain data under fair data principles, support persistent representations of neuroscience data, robust data models with I'm not going to read all of this. I think you can see it up there. I mean, this is the standard stuff that one needs for interoperability across institutions and across scientific domains. The communications platform is underway. Nicholas Stickoff at the University of Montreal, and recently we've added Lara Boyd from the University of British Columbia, and they're basically developing various levels of communication, either through blogs or webinars, web presence, and this is actually very exciting. One thing I think is worth mentioning in the broad outreach is this: the CONP is now the official back end for the Open Publishing Initiative. Was called TOPIC, it's now called Aperture, which is the official journal, open science journal for the Organization for Human Brain Mapping. This has been pioneered by Jean-Baptiste Paulin, and there are a number of people in the room who are engaged in the Aperture initiative, but it's encouraging for us to note that CONP is providing the back end for that. And something I didn't mention earlier, but the Brain Canada funding is allowing us to hire somewhere between 7 and 9 new developers in various domains across the country. This is a major commitment from Brain Canada. Some of the data sets that will be available through CONP in the next year are shown here. Starting from the top, you have the Quebec Parkinson's Network. CCNA is, as I'll mention in a moment, the neurodegenerative platform. Prevent AD is another data set on high-risk Alzheimer's disease, people with a family history of Alzheimer's disease. The Big Brain Atlas that many of you will know here, the MNI Open EEG Atlas, and various data sets that are being driven by the Ontario Brain Institute, and this slide here summarizes that in the 5 domains that I mentioned before of cerebral palsy, neurodevelopmental disorders, epilepsy, depression, and neurodegenerative diseases. So there's a wide range of data sets which will in due course be made available through the CONP platform. We're working right now on integrating these various subcomponents into a fully integrated data set. 3-body problem, 4-body problem, 5-body problem is increasingly complex. You can get bilateral interoperability, but tri- and quadrilateral interoperability presents new challenges, so we'll have to work through that. The Canadian Consortium on Neurodegeneration in Aging is an ADNI-like network across the country. The difference is that, I think I mentioned it yesterday in the business panel, ADNI is very, very restrictive in terms of the categories. They had to be clean Alzheimer's disease. CCNA has gone in the other direction and opened the gate to all comers, which is a potentially dangerous thing to do, but in retrospect is now allowing us to explore comorbidities in about 2,000 subjects using sophisticated AI machine learning approaches. Just to finish on international outreach programs, there are many, but I like to talk particularly about the so-called CCC axis, the Canada-China-Cuba axis. This is a network that we've long been engaged with Pedro Valdez Sosa, bottom left, where they've wired up the entire country of Cuba to network all of their EEG sites for screening of the entire population. He spends half of his time now in China, and so this has helped us to build what we call the CBRAIN-mediated CCC network, Canada-China-Cuba axis, otherwise known as the neuraxis of evil to surround the US. The CCC axis has various meetings in nice places, which is why we escaped to Cuba in January. Quebec is the Latin component of Canada, you understand. That's why we can be part of LabMan. We're also strongly linked with the Human Brain Project through Catherine Ammons, and a number of CONP people have been working with the Human Brain Project to develop interoperability between the Canadian initiative and the Human Brain Project. As many of you will know, there are numerous global initiatives underway to try and build bridges across large-scale initiatives around the world. One that was organized by INCF just earlier this year. CONP had a presence at that. We're also engaged in a smaller initiative that is called the Global Brain Consortium. that's focused more specifically on imaging, EEG, behavior, epigenomics, and interoperability, rather than the full panoply of all different types of data. So it's smaller than the International Brain Initiative, but we think more focused and potentially more tractable in the short term. We have an international steering committee meeting in October, made up of Catherine Ammons, Gary Egan, myself, Marianne Martone, who's here, as is Gary, Paul Thompson, the lead for Enigma, and Pedro Valdez Sosa. We'll have a workshop in the second quarter of 2019. About 50 people will be participating in that, and quite a few people in this room will likely be attending that meeting. We're also organizing a meeting with the World Health Organization, which is following on from a previous meeting that we had with the World Health Organization, to develop better translation of Western neuroscience capabilities of basic science into clinically useful applications in the developing world. And of course, we're developing further corporate partnerships, most specifically illustrated by the DELL EMC link. So with all of that said, this is the Canadian initiative. Thank you, NASA, for this. I've got to try and turn this into a joke about there's a lot of issues going on in Canada, and we have to distill it all into something that is tasty and digestible, and we hope you're going to enjoy it. We look forward to talking with you all further. Thank you very much.
Thank you so much, Alan. We probably have time for one question, if you have one question, while Josh is setting up, maybe.
Okay. So about your neurodegenerative initiative, I mean, you stressed the difference between the ADNI initiative. So what are the comorbidities that you consider, and particularly in the context of Asia, vascular dementia, and the recent one, metabolic cognitive syndrome? So that is the one with diabetes and hypertension. That is the one that, if you count heads overall globally, that is the largest component of dementia, metabolic cognitive syndrome.
Right. So the CCNA, the major clinical classes that have been included include Alzheimer's disease, vascular dementia, Lewy body dementia, I'm missing one, frontotemporal dementia. But as I've said, they're all comorbid, so you really can't be talking about these people in broad categories. The whole point of CCNA is it's allowing us to try and tease them apart. In fact, in a larger context, I like to make the point that why do we want to share data across the world? Well, it turns out that in the West, the primary form of dementia is Alzheimer's disease, but in China, the primary form of dementia is vascular dementia. So why is that? Is it genetics? Is it lifestyle? Is it nutrition? We don't really know the answer to that question, and we can't get at that question unless we're able to collect and assemble data from large amounts of data from across these various domains. And the initiatives that I just mentioned, like the CCC axis, will allow us to do that, with Canada playing a central role in the informatics of that.
Thank you. Thanks, Alan, again. You are asked to introduce yourself.